So let's talk a little bit about some other devices that are available for people with a hearing loss. It's becoming more and more common for people to be fit with cochlear implants in both ears, so binaurally. However, people may decide to only get a unilateral implant, or there might be a reason why only a unilateral implant is suitable for them. If somebody only has a unilateral implant but has a hearing loss on both sides, generally what would occur is that they have their implant on one side and they continue to wear a hearing aid on the other side. So I said that cochlear implants provide maximum amplification in the high frequency region because that's the part of the cochlea that they stimulate directly. Hearing aids are much better at providing low frequency amplification than high frequency amplification. So people who have a hearing aid on one side, an implant on the other side, and are bimodal in terms of their devices, so implant and hearing aid is bimodal hearing, tend to be quite successful users because they get a lot of the clarity of speech from their implant, and they get a lot of loudness of speech from their hearing aid, and their brain is able to incorporate the two signals so that they get a much richer sound experience. In Australia, binaural cochlear implants, again, are much, much more common than in other parts of the world, and that has to do with the way that our funding is set up, basically. It appears that if you are, especially if you're a child, if you've got a bilateral severe or profound hearing loss, you're going to do much better with bilateral implants than you are with a unilateral implant and a hearing aid on the other side, and therefore pretty much across the board, infants and children are fitted with cochlear implants binaurally. So we're incredibly fortunate in this country with what we're able to offer infants and children in terms of implantation. There's still quite a bit of research on the benefits of bimodal hearing that's occurring, but it all seems reasonably positive. Now, I said that the implant only connects with the basal 1.5 turns of the cochlea, and I also said that it's possible for people to have some residual low frequency hearing, and hopefully that residual low frequency hearing will be maintained during the implant process. For people who have some residual low frequency hearing but perhaps still require low frequency amplification, they can be fit with what's called a hybrid device. So it's a cochlear implant, but it also has a hearing aid attached. So it's a combination hearing aid and implant. It's suitable for people with very poor high frequency hearing, but some low frequency hearing. For a hybrid device, though, the electrode array is slightly shorter than with a cochlear implant alone. So when determining candidacy for a hybrid device, they have to be really quite discerning, because if the client then goes to lose all of their low frequency hearing as well and requires a cochlear implant alone, generally they'd have to be explanted. So they'd have to have the internal components removed and then re-implanted with a longer electrode array. And that's actually very traumatic for the client, very traumatic for the ear. So, there's only a small sort of subset of people for whom a hybrid device is suitable. The benefit depends on good implantation technique and preservation of residual hearing. Okay, the next implantable device is a BAHA. A BAHA is a bone-anchored hearing aid. It's basically a surgically implanted bone conductor. So a cochlear implant is really good for people with sensory neural hearing losses, but for people with permanent conductive hearing losses, a BAHA is a good solution. So people with anatomical issues, perhaps they have microtia and atresia, can't wear a conventional hearing aid and therefore need a bone conductor hearing aid. In the long term, it's much more useful and much more comfortable to be surgically implanted with your bone-anchored hearing device. Some degrees of mixed hearing loss are suitable for BAHA fitting, and there is a group of people who use BAHA fitting for single-sided deafness. So normal hearing on one side, total hearing loss on the other side. You get a BAHA fitted on the dead ear, and basically sounds coming from that direction are sent via bone conduction and heard or perceived in the other ear. The benefit is difficult to determine. For someone who's going to get a BAHA for single-sided deafness, they really need to have a very extensive trial with a bone conductor hearing aid on a headband to see if it's going to benefit them. This is a BAHA. Basically, a hole is drilled into the mastoid process of the temporal bone, and the screw is fixed into it. The screw itself has little holes in it, and it allows for what's called osseointegration, where basically the bone grows through the screw and then is able to hold it in place. It can take a little while for that process to occur, so BAHA surgery is sort of a longer term thing than cochlear implantation. Cochlear implants can be switched on a week or 2 weeks after implantation. It can take a couple of months for the BAHA to be able to be used after the surgery has occurred. So they get the screw implanted, and then they can screw into that screw what's called an abutment, with this part here, and then the BAHA basically clips onto that. So this is a bone vibrator. It's got microphone, it's got sound processor. It's basically very, very similar to a conventional hearing aid, but rather than stimulate acoustically, it's going to vibrate the bone. And this is just a picture. So you've got the screw, then you screw in the abutment, and then you attach the BAHA. And this is a picture of someone who has, so the abutment is attached to the screw, so it looks like a little press stud, and then you attach the BAHA to that. Okay, so that's our implantable devices. There are some other implantable devices. They're really quite niche in terms of who they're suitable for. So that's, for another time. If you continue on with audiology, then you'll learn a bit more about those devices. But these are the more common implantable devices. So moving on quickly to assistive listening devices. Any device that is helpful for a hearing impaired person that is not worn wholly on the head or body is termed as an assistive listening device. And there are 3 main categories. So the first category is a device to improve speech intelligibility. The second is a device to detect environmental sounds. And then the third is miscellaneous devices. The most common devices to improve speech intelligibility are FM systems. Now, FM systems can be used in conjunction with hearing aids. They can be used in conjunction with cochlear implants, or they can be used standalone. An FM system is something that we would recommend any hearing impaired child use within a classroom situation. The teacher wears a microphone, and the signal is picked up by the microphone, sent via FM to either a receiver worn by the child and then with headphones, a receiver like this that picks up the signal and then sends it out to a loudspeaker that's placed within the ear canal but keeps the ear open. This is much more acceptable to children because it's not as noticeable as the headphones. Or a receiver that is attached to their hearing aids or their cochlear implants, and then they hear the sound directly through their hearing aid. So the big benefit of an FM system is that you get the input direct from the speaker to the hearing aid. You eliminate the effects of background noise and the effects of degradation of the signal over a long distance. So it's really quite critical for a child in the classroom. So any child using hearing aids or implants in a classroom should have an FM system as well. It used to be the case that the child had to manually turn on and off the FM system or the components to their hearing aids. And it used to be the case that the microphone of the hearing aid or implant was switched off when the FM was in use. Now, that's actually a bit of a problem for children in the classroom in terms of management and also in terms of isolation. So the teacher is talking, yes, and they're the important signal in the classroom, but what if the child wants to hear their friends who are sitting next to them? If it's sort of one or the other, they're more likely to just remove the FM system and not use it. Nowadays, a lot of the systems have what's called voice-operated switching. So if the teacher is talking and that is the dominant signal being picked up by the hearing aid or cochlear implant, then that is what the child hears. Once the teacher stops talking or the teacher turns off their transmitter, the microphone of the implant or the hearing aid is switched on immediately, and therefore the child can hear their classmates. So it's less isolating. And some systems also allow for the microphone and the FM to be on at the same time. So a lot more flexibility, a lot more user-friendly, and therefore a lot more acceptable to the population. Okay, other devices to improve speech intelligibility, classroom amplification. So the teacher can wear a microphone and that can be sent to a series of loudspeakers, which is what happens in the lecture theatres here at the university. Table microphones for use in meetings. So you put a little microphone in the middle of your meeting table, the microphone picks up a signal, sends it to the hearing aid or the implant of the user. Generally, these use FM transmission as well. You can have FM or infrared systems that you use with the TV, either sending the signal from the TV to headphones worn by the client or the hearing aids or the cochlear implants. And then we've got the telecoils, which we've talked about before. So the telecoil will pick up that magnetic signal that is produced by, say, a telephone, or it can be picked up by a magnetic signal that is produced by an induction loop. So I said that people can use their telecoils at the cinema. What you will find at the cinema is that they will have an induction loop, which is basically just a double coil of wire that either is in the ceiling or in the floor of the room, connected to the sound source. The person with the hearing loss sits within the area that is looped, and they can switch their hearing aid to telecoil, and then they pick up the sound of the movie directly, and their microphone is either switched off or their microphone remains on, depending on how the hearing aid is set up. But again, it allows a direct it allows them to hear the signal directly from the movie or whatever's being projected or displayed, eliminating the effects of background noise and distance, so making it easier to hear. Okay, devices to detect environmental sounds, vibrating alarm clocks. So if you have a hearing loss, you can't hear your regular alarm, you can get something called a shake awake, which is a vibrator that you put under your pillow, and basically when the alarm goes off, it shakes the bed quite vigorously. They're less common now because most mobile telephones are able to use a vibration in order to wake you up when your alarm goes off. So that's a more common solution for people now. Doorbells that are either connected to the lighting of the house and turn the lights on and off when somebody rings the doorbell, or a doorbell that has a different tone. So perhaps it's a loud, low frequency tone rather than your high frequency doorbell. Vibrating baby monitors, all kinds of devices around the house can be connected to a vibrator box that you can wear on your belt, and then you can get a signal sent to that. Smoke alarms can be set up specialist smoke alarms can be purchased to send a signal to a vibrator as well, or you can get smoke alarms that lead to flashing lights and so on and so forth. The final category is miscellaneous devices, and there's really only a few miscellaneous devices. I said previously that if you're using your hearing aid with the microphone on, you put the telephone up to your hearing aid, it can start the hearing aid whistling. You can get a special sort of foam attachment that goes on the headpiece of the headset of the telephone. So you put like a little foam thing here, and then when you put it up to your ear, it actually creates distance between the microphone and the phone itself. You can still hear, but you're less likely to get feedback from your hearing aids. So it's little solutions like that would be miscellaneous devices. Okay, so that's it for this module. What I'd like you to do is there's a forum at the end for questions. So if anything has come up that you are unclear about, put it in the forum. You can answer other people's questions, but I'll have a quick look through next week and see if I can answer some questions too.